Hello, dear students. Welcome to the channel and welcome to this playlist in which we are discussing about 8051 microcontroller. Up until now, we have discussed about the architecture of 8051 with the block diagram of 8051 microcontroller in detail, and we have also discussed about the features of 8051 microcontroller. So now in today's class we are going to discuss about the pin diagram of 8051, and also we are going to discuss about the general purpose and specific purpose registers in detail. So firstly, here, if you have the knowledge of architectural diagram of 8051, it would be beneficial for you to understand this. But even if you haven't, then still you will be able to grasp it. But I reckon that you watch the architectural diagram video so you can grasp the concept in a better way. And no worries, we got you covered. The video will be flashing on the top right hand side corner of your screen. The link for the video will be flashing on the top right hand side corner of your screen for the video of the architectural block diagram of 8051 microcontroller. So you can check it out from there, and then you can come back here. But if you have already checked out that video, then let's continue with the pin diagram. So as you can see, this is the pin diagram of 8051, and it consists of total 40 pins. As you can see, all 40 pins serve some specific purpose. So the first 8 pins that you are seeing here, which goes from P1.0, 1.1, 1.2 up to P1.7, these 8 pins, which means pin number 1 to pin number 8, are collectively called port 1 pins or port 1, right? The port doesn't serve any other functions. It is internally pulled up, and it is a bidirectional input output port. Then there is the pin 9, which is the reset or RST pin, which is used to reset the microcontroller to its initial values. So this would differentiate my microcontroller into two types of pins. Then we have the pin number 10 to pin number 17, which goes from RxD to RD, right? So these pins are known as the port 3. So collectively they are known as port 3 pins, and this port serves some functions like interrupts, timers, control signal, serial communication signals, etc. So you can see this is the R cross D signal. Then we have the T cross D signal. Then we have the interrupt 0 and interrupt 1. These interrupts are arranged in a priority wise. So interrupt 0 holds less priority compared to interrupt 1. Then we have T0 and T1. And then we have simple. T0 and T1 are basically timer inputs. And then we have read and write signals, which are basically control signals, you can call. So these pins are known as port 3 collectively, pin 10 to pin 17, right, up until here. Now this pin 18 and 19 looks familiar from pin from 8085 as well, XTAL2 and XTAL1. So these pins are known as port 2, which serves as the input output port, and higher order address, okay, apologies, this is clock, not input output, sorry. So these pins are used for interfacing the external crystal to get the system clock. So these two pins are used for clock signals. Okay, so this is not port 3, sorry. These two are simply clock signals. Then we have the pin number 20, which is ground, right? So it provides the power supply to the circuit. Simply it grounds the supply. After that, we have pin number 21 to pin number 28. So as you can see, it goes from P2.0 to P2.7. So it goes from A to A15. So if you have studied about the address and data buses, then you would know what is it, right? These pins are collectively known as port 2, and it serves input output ports. Now higher order address, the bus signals of higher order address are also multiplexed using port 2 or this port, which starts from pin number 21 to pin number 28. Okay, so total 8 pins in the in port 2 as well. Then we have 29, pin number 29, which is PSEN, which stands for program store enable. Okay, PSEN stands for program store enable, and it is used to read the signal from the external program memory. Okay, we use PSEN to read the signal from external program memory. If you want to read the signal from any external device, then you would use this PSEN pin. Then we have the pin number 30, which is ALE and program, right? So this is EA pin, which stands which 31 is EA pin, 30 is ALE. ALE stands for address latch enable, and used for demultiplexing the address data signal of the port. Pin 31 is the EA pin, which stands for external access input, and used for enable or disabling the external memory interfacing. Okay, if you want to enable or disable the external memory interface, then you are going to use EAVPP pin. After that, we have pin number 32 to 39. These pins are known as port 0. So you can see that it goes from 32 to 39, which means 32, 33, 34, 35, 37, 36, 37, 38, 39 total. How many pins? Total 8 pins again. And these pins are also again known as port 0, and these pins also serves as input output port. So the lower order address and the data bus signals are multiplexed using this port only, right? Pin number 32 to pin number 39. And as you know, this is AD0 to AD7 pin buses, so they are used for lower order address and data bus signals, right? And finally, pin 40 is the VCC, which is used for power supply, which is used to provide the power supply to my microcontroller circuit. And that would be the pin diagram of my microcontroller 8051. So again, if you see, you can divide it in these much parts. First, this part would be called pin number 1 to pin number 8 will be called port 1. Pin number 9 is reset. Pin 10 to 17, this pin 10 to 17 are port 3. Then 18 and 19 are clock signals. How many categories are there? We till now we have calculated total 4. Then let's collaborate ground signal with VCC, so it will make 5th category. Then we have this pin 21 to 28, 6th category. Pin 29, 7th category. 30, 8th category, and 31, 9th category. And then 32 to 40. So total 10 categories you can calculate, sorry, 32 to 39. So that would be 10 categories if you if you count. But what we can do, we can combine these three categories, as you can see, 29, 30 and 31, and give it a name, right? Give it some name. So by that way, some books prefer that way as well. And if you calculate that way, then we would have total 8 categories the way we distribute the pins in 8051. So that was the pin diagram of 8051. And now if you want to relate it with the architectural block diagram, then you may you may be able to do it, right? And for that, I'm again recommending you the previous video so that you can learn and understand about that as well. Now moving forward, let's see the general purpose and specific purpose registers, which we have discussed earlier, but this time I want to discuss it in detail, right? When we were discussing the architectural block diagram, we have discussed about it, but we only took the small glimpse of it. So this time we are going to discuss it in detail. Okay, so let's start from general purpose and specific purpose registers. So first we have the internal memory. For the proper operation of the computer system, the system should have memory from program code, right? And the memory from program code is normally in the form of ROM or RAM, random access memory, and read only memory. So the data can be changed when the program is executed. So just like any good microcontroller, 8051 also has the internal RAM and ROM, and also you can connect any external ROM whenever required as well. So if this memory is insufficient, then you can connect the additional memory in form of external ROM, sorry, with the use of suitable circuit. But first, let's see the internal RAM. So the 8085 controller has 128 byte internal RAM only. And one more time, remember, this is the old technology, this is not the new technology. So the storage capabilities might surprise you. So it has only 128 byte internal RAM, and the internal RAM is organized in three different areas. There is a four there are four register banks of 8 bytes each. So that would make how much, total of how much, 32 bytes. Then we have the bit addressable area of 16 bytes, and then we have the general purpose RAM area, right? The scratch pad area. So in this image you can see that we have four register banks: bank 0, bank 1, bank 2, and bank 3. These four register banks, and each of these banks have 8 bit, uh, each of these register banks have 8 bytes of storage each. You can see the bank 0 starts from 00H and it goes till 07H. So if we calculate, it would be 8 bytes. Then we have 08H and it goes till 0FH. It again it is 8 bytes. Then it starts from 10H to 17H, and then 18H to 1FH. And also remember that the numbering system which we are using here is not the regular decimal numbering system. In 8051 you always use what system? It's hexadecimal. Okay, hexadecimal system that we use. So these four register banks, which are numbered 0 to 3, and each bank is made up of total 8 registers, and these 8 registers are named R0 to R7. So in total there are 32 bytes, or 32 working registers from address 00H to 1FH, which are organized as a 4 register bank. And then for selecting a register bank, 2 bits RS0 and RS1 are provided in the program status work, or PSW. With the help of PSW, or program status work, you would be able to select the register bank of your choice. Then if you have the register if any of the register banks are not selected, then the programmer can use the area from 00H to 1FH as simple scratch pad RAM or general purpose RAM as well, right? So this area, if not a single register bank has been selected, then you can use it as a simple scratch pad RAM as well. Okay, But there is one more thing which you have to consider, or always be careful about, that whenever you turn on the power or reset the microcontroller, then the bank 0 will be selected by default only, right? So you have to deselect it if you want to use it, use this area as a scratch pad. So always remember that. After that, starting from starting from here, we have the bit addressable RAM area. This area is made up of 16 bytes. So our microcontroller 8051 has the reserved 16 bytes of internal RAM whose address ranges from, see, it starts from 20H, and then it goes to, how far it goes till 2FH, right? So these 16 bytes provide us within 128 bits are forming the addressable bits, right? So as you can see, the microcontroller has given the address to the bit ranging from 00 to 7FH. See, it starts from bottom right hand side, it starts from 00, then 01, 02, 03, 4, 5, 6, 7. So this is 8 bit. After that we will have the remaining 8 bit, 8, 9, 10. Instead of 10 we write A, because this is the hexadecimal numbering system. So A, B, C, D, E, F. After F we will start from 10, 11, 12 till 17, then again 18, 19, again 1A, then we will go till 1F. After that, from 20 till 2F, 30 till 3F, 40 till 4F, 50 till 5F, 60 till 6F, and 70 till 7F. So these 16 bytes provide us with 128 bits forming addressable bit, and the microcontroller has given the address of these bits ranging from 00 to 7FH. Hence, these locations are called bit addressable locations. So the whole portion, all the uh, locations are called bit addressable locations. The addressable bits are useful if the binary event in the program needs to be remembered, right? So anytime you want to remember the binary event in your program, then always remember to use these bits, right? Bit addressable RAM, always remember to use the bit addressable locations or bit addressable RAM area, right? And if you don't know what are the binary events, then simple open switch and close switch operations are the binary events, right? 0101 events, for example, 0101 events, right? So simple open switch and simple close switch are binary events. After that you have the general purpose RAM area. As you can see, is it starts from 30H and it goes till 7FH, right? From 30H to 7FH, which means it requires the largest portion of the RAM, right? Don't mistake it for a small area, because they drew it smaller, but consider it a larger area, because we broke the line from here, see, right? So it's starting from 30H and it is going till 7FH. See, this started from 0H and it went till only 1FH. So it is 7 times smaller than this. Then it started from 20H and it went till 30H. So again, it is 7 times smaller than this. But see, sorry, not 7 times. It is 5 times smaller than the general purpose RAM area, and this is also 5 times smaller than general purpose RAM area, or 4 times. Sorry, and it is larger. General purpose RAM area is larger because it is going from 30H to 7FH. And this RAM area is also called the scratch pad area. Sometimes it lies above the bit addressable area and has addresses 30H to 7FH, as I've said. And this RAM area can be used as a data RAM as well. So the memory in this area is byte addressable memory, right? It is a byte addressable memory, and the programmer may declare the stack in this area, provide sufficient number of bytes which are available here as well. So programmer can use it as per its convenience, as per his convenience or her convenience. He can declare stack in this area, provide sufficient number of bytes which are available, and anything, right? So it is very useful area. And as you can see here, this LSB, it stands for least significant bit, right? Now collectively thinking of the whole memory or internal RAM, because this is the structure of the internal RAM only. So what is the application of this internal RAM? Why do we use it? So it is not essential to utilize the entire area of the internal RAM of the microcontroller as a scratch pad, right? Because we have the bit addressable RAM as well. So you cannot do that. The microcontroller has the instruction that allow the internal memory locations to be used as the data pointers, right? So it has the instructions that allow internal memory locations to be used as the data pointers. And the registers R0 to R7 in the four regional register banks. You can see here bank number 0 to bank number 7. Sorry, bank number 3. These can be used as the pointer to point the internal RAM as well as the external RAM. Okay, so you can use them to point the internal RAM, but not only internal RAM but external RAM as well. And when the registers R0 to R7 are used to access the external RAM, the microcontroller will require a 16-bit address. Okay, so you know what's going to happen now, because 8085 is a 8-bit microcontroller. The size of the address generated will be 8 bits. So these 8 bits is treated as the LSB, or least significant bit of 16-bit address, and MSB, or most significant bit, is taken to the 00H by default. Okay, so most significant bit will be taken here by default, and LSB would go here, right? So that was the application, except that microcontroller 805 8051 also has the internal ROM. And I think you, if you are studying microcontroller on microprocessors, then you might have the idea of difference between RAM and ROM, right? RAM, if you don't have, no worries, I will explain it in very short. That RAM is random access memory, so that memory can be will be erased when you turn off the controller or reset the controller or processor. But ROM is the read only memory, that is something that only accessible for reading. And also it does not wash away when you turn off or reset your microcontroller or processor. It is the memory which gets stored on the processor, on the board, right? So this memory is a separate memory from program and the data in and I'm talking about microprocessor 8051 only. So in microprocessor 8051, we have the internal ROM which is separated from the program and data, and both these memories have same address ranges. Okay, so the internal ROM is used to store the internal program code, and it occupies the address space which ranges from 00H to 0FFH. Okay, so what is the range of internal ROM of microcontroller 8051? So it ranges from 00H to 0FFH. And the program counter can access the program code bytes from 0000H to FFFFH, right? So the capacity of internal ROM would go from 0H to 0FFH. And for addresses higher than 0FFH, the 8051 will automatically fetch the program code bytes from external memory by connecting the external access pin external access pin to the ground. Remember external access pin, which we discussed few minutes ago. Let me take you there. See this pin number 31, EA. So we will use that pin. Okay, we will use Pin number 31, EA or external address pin, and by using that 8051 will automatically fetch the uh, program code bytes from external memory. Then the program counter is not bothered of about where the program code is resided. The programmer will decide whether the code resides in the internal memory or external memory or combination of the internal and external memory. So being the programmer, you have to decide whether you want to reside your code into the internal memory or the external memory, or you want to reside half of your code in internal and remaining of in the external, right? And speaking of external memory, let's discuss about external memory in detail as well. So firstly, external memory is used in the case when the internal ROM and RAM memory are available on the chip is not sufficient, right? Because remember, this is the old technology. 8051 is around 40 years old technology from today, which means it used to have very less amount of RAM and ROM storages, right? And because of that, we had the requirement to use the external memory. So we use the external memory when internal ROM and internal RAM are which are on chip are not sufficient. So two separate external memory spaces are made available by 16-bit program counter and the data pointer, and by different control pins from enabling external ROM and RAM chips, right? So what do? We take two separate external memory spaces which are made available by program counter and the data pointer, and by using different control pins we can use the external ROM and external RAM chips. Now if 128 bytes of internal RAM is insufficient, then external RAM is accessed by data pointer, and in 8051 family the external RAM up to 64 KB can be added to any chip. Okay, so again I'm telling you how much internal RAM does 8051 has. 128 bytes, right? And if 128 bytes internal RAM is insufficient, then you can uh, access the external RAM with the help of data pointer. And what is the capacity of external RAM that can be connected to 8051? So 8051 family can connect the external RAM up to 64 KBs to any 8051 chip. Okay, and the external ROM for ROM of up to 64 KB can also be added to any chip in every single 8051 registers, sorry, 8051 controllers. Then we have the special function registers, which I want to discuss about. As you can see here, these special function registers are placed in the address space immediately above 128 bytes of the RAM from address ATH to FFH, right? So they are placed in the address space immediately above 128 bytes of the RAM from address ATH to FFH, and in 8051 microcontroller operations which don't use the internal RAM, the 128 byte internal RAM are accessed by a group of specific internal register which we call specific functional registers or specific function registers or SFRs. So the SFR memory consists of important registers like it consists of accumulator, the B register, the interrupt control registers, PSWs, the timers and counters, the power control, for input output parts, the serial ports. So all these internal registers are operated by SFR or special function registers, and some of these registers are bit addressable while remaining are the byte addressable. So you may have to check whether the register you are looking forward to use is bit addressable or byte addressable. Some of the addresses are locations in between ATH and FFH. As you can see, it starts from ATH with pin P0 and it goes till 0F0H, right? So it starts from some of the addresses are locations between ATH and FFH, and these addresses are some of the addresses are not used at all. See, there is blank space, there is empty space between this and this and this. See, right? This is not the decoration. These spaces are not being used here. So if we try to use one of these unused locations that are not defined or are empty, then we may get unpredictable result. So it is better to not use the empty or undefined locations in 8051 microcontroller. And one more important thing, or the clarification, that program counter is not the part of SFR, right? So program counter is not a special function register. You can see the port 0, you can see the TCON, SCON, you can see port 1, port 2, port 3, right? You can see EI and EP, you can see PSW, you can see B register, accumulator, but program counter is not part of special function registers. So the program counter does not have the internal RAM address as well, right? And the SFR or special function registers are named in some opcodes, and by their functional names, like A stand which functional name A stands for generally stands for accumulator. We have PCON, P1, P2, P0, the ports. So these are referred by opcodes by their addresses such as E00H, 87H, 90H, A0s, 0A, 0H, 80H, right? Based on that, based on that, we number them or name them. So these are my special function registers. And if you see, it starts from P0, which is located at ATH, and it consists of 1, 2, 3, 4, 5, 6, 7, 8 registers. And you can also check in the pin diagram as well. See, the P0 stands for the zeroth port. So you can see how many pins the zeroth port has: 1, 2, 3, 4, 5, 6, 7, and 8, right? So it consists of 8 ports, sorry, 8 pins. Same ways we have the TCON, which consists of 8 pins again. It starts from 88H. Okay, not 8 ports. It consists of two pins only, right? 80 from 88, then it goes till 90. Then from 90 P1 starts and it goes till 98. Then SCON starts from 98 and it goes till 0A0, right? Okay, it also, so TCON consists of 8 registers, SCON 8 registers, right? Because remember, this is a hexadecimal system, so I made a mistake earlier. It does not consist 2, it consists 8, because this is a hexadecimal system. Then EI, IP, PSW, accumulator, and B. So we get our special function registers. In the next class, we will see different ports in detail, and we will also discuss about the timers and the counters of 8051. If you have any queries related to today's class, if you have any question related to today's class, please feel free to mention them in the comment section below. I will try to answer them as soon as possible and as many as them possible. If you have any suggestions or feedbacks related to the classes or lectures, mention them in the comment section below as well, so I will be able to answer them as soon as possible. And please subscribe to the channel so that I can understand that you are getting a liking to your to the channel and videos or not. So we will keep today's class till here. I will see you in the next class with new topic. Till then, take care of yourselves. Thank you very much for listening, and goodbye for now.